Vidovic holds a bachelor's degree in architecture and is currently pursuing her master's degree at the Institute for Advanced Architecture of Catalonia in Barcelona, Spain. She has skills in conceptual thinking, BIM, computational design, graphic representation, machine learning, and digital fabrication. Her thesis aims to develop an Autodesk tool using agent-based modeling to create an AI assistant for data-informed early design stage decision-making, which is what she has been focusing on in her residency with us and what she will be sharing more about today. So I will hand it over to Anastasija.
Thank you very much for the introduction and for the opportunity to present. I'll share my screen now. I hope you can see it. So I can start, right? Great. So today I'll share with you some aspects of the research I was developing through this year and the functional prototype I worked on while I was in Autodesk. My work explores ways to bridge the gap between human intuition that allows for exploration and creativity and computational precision. Throughout my studies, I heard many different definitions of architecture and the role of an architect. And at its core, architect translates visions into instructions. And for a long time, architect's vision was the primary tool for synthesizing complex design inputs that come into consideration in design, that in this work will be referred as flows. Looking back at design history, we will notice how different flows were serving as driving factors for designing for designing process. And depending on what tools we had at the time, it influenced how architects approach the design. So with today's tools, maybe it's a bit optimistic, but it feels like we have finally enough computational power to process them simultaneously. But what comes with an ability to do something is also a responsibility for this action. And today we can already observe how with integration of softwares in architectural workflow, the decision-making process was shifted to be at early design stages. Essentially, what happened is that softwares introduced large amounts of data into modeling environment. So it became necessary to consider long-term consequences from the very beginning at conceptual phase. Meanwhile, architects remain the ones who are responsible for decision-making and for synthesizing those flows. And this raises the question of the role of the software in designing workflow, and most importantly, its position in design workflow. Right now, it stands between architect and design with intention to improve the design. So it's more like a functional aid where the tools that we have now, they try to adjust design parameters, but the goals are still set by architect based on the initial assumptions. And this is raises like a necessity in a tool that will maybe stand in a different position between architect and the data. So the intention of this tool will be not to improve the design, but to improve designing process. So it will be kind of an assistant tool that will support architect in decision making and in the process of synthesizing parameters for the design. Now, what is complex about designing process is that design outcome is not predictable from design inputs because the design itself is something more than just reading of parameters. And this is what makes us think of architecture as a complex system. And nature has the most advanced tool for dealing with complexity. So I looked at some natural workflows, and what I found interesting on how nature operates is that it does not translate signals received from the environment and instructions that are stored in information storage directly into the commands. So to actually form the response, there are some intermediate components, some natural agents that allow for reading the data and processing the data. This is where we can draw a parallel with architect's workflow, and again question our relationship with softwares. So this work suggests a way of using the software, like interacting with the software through intelligent agents that will serve as kind of design partners for an architect that will help him to learn the data about the project and to make sense out of this project data. Meanwhile, making sure he remains the control over the designing process. So, as I said, these agents, they will stand between the data and the decision making, but with possibility to involve users' feedback. Practically, how it will work is that available values from the model will be compared to required values for the project data. So what we want to have in terms of design versus what conditions we have for this. And of course, with architect's opinion, like with his control on the top of that. So through the comments, he can influence this process. So the idea of it will be that this thinking will happen directly into the modeling space. So parameters will be extracted automatically. For this, a system workflow features different windows, one for uploading the information, like for reading this data. Then the other window will be for communicating with this data. So this is where architect, like if he mindlessly uploaded this data, where he can actually learn what he needs to design. And finally, there will be a window that will allow to start exploration already in modeling space through prompting the agents. So now how text 3D workflow will look like. There will be some operations that run by the default when the files are uploaded. The goal of those operations will be to form different levels of preferences for the decision, first on the agent level and then on the system level. After which, in the modeling space, there will be form vectors, and the outcome, like emergent outcome of this process, will be something that is called flow boundary. It will be like visualization of internal model processes, looking at which architect can quickly understand the dynamics of this data. So the idea will be that architect do not have to think about the numbers. He can work more like on a visual way. And this is where we get this feedback loop. So by looking at it and observing it, architect can influence the process by sending direct comments that will affect this decision-making process. Now in 3D, agents are basically vectors. They exist in a sort of environment with data points that store some information from the model. There are also defined relationships, and there can be also some objects. Objects are basically any physical elements inside the environment that are also linked to values in project data. So you can think of it like if you have to plan something on site and you have some constraints. For example, you have a water line going through the site and you need to keep the distance. So the water line itself is an object and the distance is a value that agents operate with. Now these decisions like this, they are not summarized. So there is not one vector that is formed. Instead, agents, they have different roles. So there are sensing agents that tend to explore the data. They build vectors to the nearby points. So they consider the surroundings. And based on their individual preferences, some vectors, some attractors are stronger than others. Meanwhile, the processing agents, they're linked to the project data, so they make something more like predictions. So based on the available information, they suggest the direction of movement. And finally, there is a possibility of user to insert his opinion. So there is another directory vector for that. An idea of this is like constant dialogue between these three. Now to orient inside environment, agents have something called vision cones. They control amount of data that comes into consideration in each iteration. This is very important because agents are linked to the project documentation, but they are not processing the full amount of data. Because if they would, they will eventually end up with optimization. So they will skip exploration process and jump directly into conclusion, saying like this is the best position. But this is not what we want, because if the tool is supposed to be interactive and iterative, we need these steps between. So the agents, they explore the data alongside the architect. This is a little preview. Now you can see how the color changed. This is because the model, it visualized the interactions that happen. So by previewing this color, architect make like it signals for the architect what's happening with these specific agents. So architect can look at this in the simulation mode, where he can control individual parameters and affect it somehow. And when he already has some conclusions, he may preview the flow boundary, like which displays the system performance as a whole. Basically, it's just mapping of the same data, but on some mesh. So he can keep it as an underlayer and start modeling, because this tool, it's not for modeling, it's for thinking. So the idea of having creative thinking process inside the modeling environment, but the outcome of it, like the formal outcome, is not the design, but the process of designing. So some conclusions. And after that, architect can start working like the way he prefers. So to prove this workflow, I tried little experiment with designing some residential space. So I linked agents with some data on spaces, like their physical characteristics as areas, and to the sun hours. Sun hours parameters was chosen because like it was easy in terms of having these dynamic interactions, as they allow for shadowing, and I could test agents with repetitive behavior. So this is the data agents were fed with. I had to do some prior work to it, like for example, activities, they were scored based on their duration, intensity, and frequency. But overall, it's just some intuitive data. And this is the preview of how it worked. So, as I said, first step is to upload the document. Then the parameters are right and left for the user for the preview. Then he can set some like environment boundaries, what he works with. There can be some additional parameters like topping criteria, or like any rules, like borders rule, not to come close to the borders. And here I just show how to input parameters manually. This is not required to do. I just wanted to do it for the video, so it would be understandable how they are connected. Now this is the dialog window. There are some prompt suggestions that appear when you start typing. And you can ask questions and get some answers. And then you can come to the modeling space. So this is the simulation preview. So the colors indicate like whether the space gets enough sunlight or not. So we can see that the blue ones, they do not have enough sunlight. So by looking at this, architect may think like, okay, I can do something about this. And this is the stop-in criteria. It's just to ensure that if the no input is provided, it just stops. So this was the like formal outcome, and this is a flow boundary that he can keep for the further steps. So the workflow from what I have now, it's have some features that allow to use it as an exploratory tool, but there are many things to improve, starting with the maybe more understandable workflow, because I use prompting, but it's still not that clear like what you can do with agents, like how you can navigate them depending on the different types of data that you have. And also visualizations, I use signaling with colors because it's easily interpretable, but maybe there are some other layers of information that can be previewed. Right now, I'm working on integrating reinforcement learning into it, so the agents can improve how they interact with each other and with the environment. And another step will be to test with Autodesk docs, because they already have all these instruments for connecting the project documentation. So maybe it would be a good additional experiment. And finally, what they have to work on is to try to make it independent program, because for now, I don't have it in the format that I can share it with someone, like to send it and he can run it on his software. So this cross-platform compatibility will be important future step. Now, as you may noticed, at the beginning, I was talking how the different stakeholders are involved into decision-making process. Like we have data from city, like site data, and data from client, project brief, and then architect's vision. But my interface, like in the state that I have it right now, is designed from the perspective of architect. So but in real life, it's always these communications that happens. So to open up a discussion, I designed some imaginary interface that is designed in a game-like setting with different roles assigned based on functionalities and features that each team member has. In some way, this is something that already exists in like BIM softwares and like in Revit, but the idea was to just visually design it, so I can show how agents and AI assistant can be integrated into this process. So this is not functional software, this is just visualization of a workflow based on the features that I just described to you. This is how I imagine it could work if I could insert there more users. So this is like the process of this visual thinking through the data, and then this is the flow boundary. Again, flow boundary is just one possible way for viewing it. Okay, so thank you very much, and I'm looking forward for your opinions and questions.
All right, thank you so much, Anastasia. We'll open it up for questions or comments, feedback.
And Cesar, very compelling presentation, and I really love the content that you're showing. I have a question about uh, this is a tool designed for architects in the early design stages, but do you have any thoughts on how this might be applicable in, or like would somebody from construction persona, or like somebody from other AEC fields, how would they use such a system with agents?
Honestly, I feel like I don't have even enough experience within my own field, like within architecture. to provide all the answers, but I think the idea of it was to improve the very early stage when we don't have any like physical definition of space, when we only start with perimeters. And other professionals, they mostly work when on later stages, like when there are some things already defined, because they work on developing the design, not on the creative part of it. So this tool, it was not about the outcome, because I can't say like using this I can produce better designs, but I might suggest that by using this I can work it will be more convenient for me to work, because I don't have to like first study the data, then to make some visualizations like sketching, and then start modeling, because it's really hard. And I felt like it a lot with other students from my university. Like sometimes students even fear to approach the software, because you don't know where to start. You have a lot of things to include, but you don't know where to start. So the idea was to make this process easier and inside the software. I don't think it's like it's it was another target. But thank you for the question.
Yeah, thank you. And yeah, and I think it's a super cool tool that you're building. And yeah, as you were showing like the initial like the first few slides, I was thinking this would be a very useful capability for say like in construction during pre-con, or like in scheduling. Something similar to what you showed would be directly applicable. That's thank you.
Yeah, go ahead.
I loved your, okay, thank you. I loved your presentation. I wanted to see in terms of evolution of this, are you planning on piloting it with, a few people, a few firms to see how it helps the design process, or what's next?
So I just I just completed it. So like I just defended it at my university at the end of September. Now I enrolled in Autodesk residency program. So I don't know. I don't have a team or someone to develop it with. So for now, I'm just keeping it as a research and trying to do what I can, depending on my knowledge and abilities. So I don't think I sort of feel this serious yet. But I would be happy to do this, because I'm very much motivated, and if there will be opportunity to do something about it, I would definitely do.
Maybe a better question is, how do you hope, what progress do you hope to make during the residency program with your project? Yeah.
So, like basically the future steps that I listed here, I need to try it with existing Autodesk software, because this is where most architects work. They already have a good environment that allows for exploration, and also this reinforcement learning thing. So yeah, and to make it, as I mentioned, to make it independent piece of program, so I can share it and get like more opinions about it, because now I only show it like a demonstration, but it would be nice to get the feedback if it was actually shareable, so I can know like how people felt while using it. Thank you.
I've got a question about the visualizations. It was kind of neat, the visualizations you showed. They're fairly abstract. You can imagine the opposite being a visualization that's very detailed, where you could see you could see the building, you could see every single agent. Maybe they've got arms and legs and clothing and they walk around. I'm curious, do you see a benefit in using a more abstract representation with the spheres and cones and something that's not too concrete? I'm wondering if you have any thoughts on that.
So to actually come up with visualization, I would need to test it on a larger amount of data, because right now I took like the simplest task. So I had the data on spaces and on some of their requirements. And we can imagine that in like urban scale, they have like many parameters. And even on like if I had a site and I had the site data, I would already had more information sources. So if I would have the data and I could test it with like, because it will become more complex right now, it's in a scale of like those bubble diagrams that architects typically make. So this is something he can visually understand. But what if we get some data from the site, some like pin patterns and other patterns that are overlayered? So this will be like more agents that we can see on the screen. And then I definitely need to come up with something else, because it won't be understandable with just spheres and cones.
Right. So you want, I guess, make sure the level of detail in the visualization matches the amount of data that you have coming in.
Yeah, I think so.
Okay, thanks.
Thank you.
Great. Any last question, comment? Otherwise, I think we're at time. Thank you so much, Anastasia, for presenting your work today. We look forward to continuing our work with you. If you have any other questions, please feel free to message our team. We do have another Research Connections talk this Thursday. It is going to be a physics-informed AI talk on machine learning and large-scale engineering simulations. So please keep your eye out for that talk as well. Thanks, everyone. Thank you, Athena.
Thank you all. Thank you so much, Anastasia.
Thank you.